how do we represent optionality in programs? So, of course, nils were bad, so other people fixed them for us. And we are, Philistines for not yet using this. And there's a couple, there are many floating around. This is not like there's one answer. There are many answers, so probably they aren't all the best. But in Haskell, we have a type called, or there is a type called maybe. It's a parameterized type, right? Maybe of some type A, and it has two constructors. You can have just an A, or you can have nothing, which is our nil. And then Scala uses a lot of things to make that same kind of thing-ish, somewhat. So I think we'll stick with the Haskell version moving forward. You will hear this said of this is the way, this is a way to do this. This fixes the problem. What's great about it is it forces you to check, right? And of course, that is the most important thing in programming, that somebody is watching you and making sure you're checking for nils, no matter what the cost, right? And the problem is no one can articulate the costs. No one ever mentions costs. This all benefit, right? But it is not, okay? So when do you see the costs of maybe? You see them in program maintenance, all right? So yesterday I had a function. It took an X and returned a Y. People wrote code to that function, right? Today, I'm like, you know what? I was asking too much of you. I actually can get by without that X. I'm now making it optional, right? This is an easing of requirements. An easing of requirements should be a compatible change, I think. So we make this change. We say foo now takes a maybe X. This is the way you represent optionality, and returns a Y. And the compiler inside foo will make sure that the code in foo doesn't accidentally fail to consider nothing, right? Woo! That's all win. Except what? This breaks existing callers. Right? This is a breaking change. It should be a compatible change, but it's a breaking change. Let's talk about providing a stronger return type. Okay, so yesterday, I wasn't sure if I could do the job in all cases. I wasn't sure I could provide a meaningful return value, so I took an X and I returned a maybe Y. But today, I figured out how to give you an answer in all cases. And so, because when I was giving you that maybe Y, you had to deal with it, I want future callers to have more certainty about what they're getting. So I want to make a compatible change of strengthening my promise. Okay, so relaxing a requirement should be a compatible change. Strengthening a promise should be a compatible change. So I do this. I changed. I said, I'm definitely going to give you a Y. Guess what happened? I broke all of my callers again. I broke my callers. Right? Because now they have code that deals with maybe, and they're not getting a maybe anymore. So what is happening here? Right? What's happening is that maybe and either, in spite of their names and the play on language in English, are not actually type systems or, no matter how many blog posts from people that just learned Scala you read and Haskell that you read. This is not or, right? This is an evidence of a type system that does not have or for types, does not have union types. And you're trying to fix it in the user space, right? And guess what? You can't fix it in the user space, right? Either in particular, wow, it is just not a beautiful thing. It does not mean or, right? It's got a left and a right. It should have been called left-right thingy, because then you have a better sense of the true semantics. There are no semantics, right, except what you superimpose on top of it. And using English words to try to give you some impression is not good, especially in this case where you're so failing to come close to or. Right? It has none of the mathematical properties. It's not associative. It's not commutative. And it's not symmetric. Right? Actually, better than left-right thingy would be sinister-dexter thingy. Right? Because at least you'd have some sense of how it treats left. It's quite poorly. So, you know, I have a reputation for bashing type systems, and I am not. I'm bashing maybe and either. Okay? But, you know, other type systems have other answers to the same questions. Right? Here's Kotlin. Kotlin has nullable and non-null types. Right? So if you say string, it's assignable from a string. That's pretty good. But if you try to assign null to it, it says compilation error. So they've strengthened the reference types in Kotlin. They've said, you know what, null is not an okay value of all reference types. Even though Java JVM allows you to have a null as a value of string, we're not going to allow it in the surface language of Kotlin, even though it compiles to bytecode. But you can have string question mark, and question mark is the way you add nullability to a type. And it creates a proper union. All the strings and null as a type, right? Because types are sets. So it's all the strings that set and one more thing. And then it's assignable from both, right? You can assign it from ABC and you can assign it from null. If you made the same changes I just described in Kotlin, you would not break callers, subject to how Kotlin links, and I don't know how Kotlin links. Dottie, the successor to Scala, that the Ardersky team is working on, has union types in their plan. And it says of union types this: union types are the dual of intersection types. Values of type A, I'm going to say or, because I think it matches. Values of type A or B are all values of type A and all values of type B and all values of type B. That's set. It's a set union, right? Or is commutative. A or B is the same type as B or A. I think this is awesome. I have never used a type system where I haven't desperately wanted this. So it can be different. Do not get lectured to by people about maybe and either. They are not the best answers in type system world.